Hello. So today we will be doing part of a new lecture series for the C++ class, which is a beginner's lecture 1 on C++. So in this new flavor, we intend to help those who are still unfamiliar or do not have much experience with programming in the C++ programming language. So we've decided to do it in these different flavors to allow you guys to walk into our course and be able to work at a level that you think is comfortable for you. So the way it works is that we're going to have a couple of classes in C++ beginners, intermediate, and advanced. And then in between that, we'll also have tasks and other things to help enhance your learning. And then once you're done with a particular flavor, you can move on to the next. And then we will just repeat this cycle over and over, hopefully to improve how we teach. So feel free to leave a comment in the Discord channel, suggest any suggestions or anything else as to how these lectures should proceed. Anyway, on to the lecture proper. So for today, we will be teaching two things, C++ basics and arrays. So let's start first with the basics. So to give you guys a bit of a brief introduction to what C++ is. So C++ is a programming language developed by, never really pronounce his name, but it's Bjarne Strass, well, whatever, But like, he's a great man. So C++ can be used in different areas, which is why it's a general purpose programming language. Often you find it used for various systems programming applications. So C++ is used in creating things like browsers, video games, operating systems, etc. It's also very useful, for instance, for other programming languages. For instance, the interpreter for the Python programming language is mostly written in C++ and, well, C. So let's move on to the real meat of what we want to do, which is actually learn how to get to with this language. Because in programming, often the best way to learn is to do it. Because it's sort of, think of it like a skill that you have to get better at. You don't you could read it, for hours and hours on a piece of paper, but never quite get it. So you need to really practice it in order to get along with it. So in this lecture, we will be using REPL.it, which is a convenient website. I'll make a separate video on how to set up a development environment for C++ on your respective systems. But for now, it's just easier to use REPL.it so that I don't quite have to go into the in-depths of how one needs to set up a compiler and etc. So what you do is you set up a REPL.it account, and I already have one set up here. But if you set one up, you can click New REPL button on the top right, and then choose Type the C++ language. Then you name your REPL, and then create that REPL. So then once you open it, you're going to see a bunch of words and characters in your screen, especially this, which I will now show now, especially this. So we're going to go into what exactly this all means, okay? So let's start with the first part, which is the int main. So this is where the program execution begins. So you see, int main is probably the most important thing in your C++ program. And the reason for this is that without this, C++ does not know where the program begins. So int is an example of a variable and needs to return a value. So int stands for integer. Therefore, an int type will need to refer to a number. So any code that is inside the curly braces is what you execute. So note that the code is read from top to bottom, left to right. So inside the curly braces, and just before I move on, I also have to explain that the reason why the main function is an int is that C++ needs to always return something. And so in order to know if a program terminates correctly, it's going to return either a 1 or a 0 or something. Sorry, it'll return a 0. And if it doesn't work properly, it'll return something else that's not 0. So this will also be the reason why sometimes you might run into this sort of thing when you program C++, which is return 0. And the reason for this is just to make it more explicit for when you want to make sure that your program terminated successfully. Because in other operating systems, for instance, like Linux, you might have different numbers to indicate different types of errors. Now, we don't really have to go into that right now, but it's just something important to hold in mind, that the reason why we call it int main instead of something else is because C++ is using these sorts of functions in order to determine if your program terminated successfully. So carrying on. Now you'll see this thing called Std, which can also be thought of as standard. You can call that standard because it refers to the standard library. Or some people also like to say a std. It's up to you exactly how you call it. So Std C out. You pronounce that C out because it stands for C output. And then 2 less than signs, and then hello world with a /n there. So what this does is it displays hello world to your console. So when we declare this std here, we are calling something called the standard library. We'll get into that a little bit later in terms of the different ways we can do that. But for now, just know that that's kind of how it works. So what this does is it calls cout, which is inside the std namespace. And so there's a bunch of different functions, many different sort of things that can be called from the standard library. And cout is one of those things that we can call from it, which displays something to the console. So So now let's get a bit familiar with the other parts of this program. Also, bear in mind, notice that there is a semicolon here. So in C++, it uses semicolons to determine what is the end of a program. So if I get rid of the semicolon, it's going to tell me that there's an error. And the reason for that is because it doesn't know where to stop. Now, if we put the semicolon back in, we're going to see that it compiles successfully. And we have a hello world displayed here. Another thing that I should also mention is the idea of this, the #include or #include IOStream. So this is what we call a preprocessor. So what a preprocessor is think of it a bit like a library that your program calls. Because inside this preprocessor IOStream, there exists this cout, std cout. And we need to call this library in order to call this function. So if think about the library as some sort of very advanced code, like code that programmers work on to make your life easier, so that you yourself don't have to do it. So when we call IOStream, we don't have to worry about all the nitty-gritty of exactly how the program is going to display something to the console. We just include it, use this thing, and now we've got hello world in the console. So, kind of makes it makes things a lot easier for us here in the year 2020. So another thing that's important is that this is represented as a string. We want to put these inside parentheses here. Now what this \n does is it is also known as a end line or something like that. Because you could also say this, but I'll demonstrate it. What the \n does is it creates a new line for your text output. So for instance, we could write something like this. I'll just copy the code to make it a little bit easier. So for instance, what that does is it creates two lines where we do that. It creates a new line. Now, if we remove this, then we wouldn't get a new line. It would just go hello, hello world like that. There's also another way of doing this without \n, and that's with something called std and del, which is just the same thing. Although technically there are some differences, but feel free to use \n or this. As you advance, you'll learn a bit more about those. Whichever is a bit easier. See, same result. And now next, we'll be moving on to. So I hope that this has been very clear. You can experiment with this as much as you like. For instance, you could make cout display something like that. And you can see that it displays that. So you can do lots of cool things. So now, we're displaying stuff to the console. That's very interesting. But, the reason why we use programming is we want to basically do math. We want to be able to do certain things, okay? So in order to do this, we need to get familiar with something called a variable. So what is a variable? You can think of a variable as like a box that where you store things in. And now this box needs to know what it stores. For instance, if you have if you're familiar with garbage cans, you have a can for materials that are recyclable. You have can for materials that are biodegradable. You have cans for those that aren't biodegradable, etc. So variables in C++ need to know what they are. So for instance, when we call this initialization, a variable, we first specify what it is. So with the data type int, as we are aware with the function here, and then we give it a name. So int favenum. Another thing too in C++ is that there tends to be a convention wherein we follow this sort of this particular case here, wherein if we say two things, we type it like that, and then we capitalize this. Forgot a little bit of what it's called. I think it's Camel Case. Yeah, I think it's Camel Case, but you can feel free to ignore that. It's just something people do. So we can specify int favenum is equal to 10. And now we have stored 10 into favenum. And we've also defined that favenum is a variable that stores integers. Now, when we look at programming in general, often the math tends to look a little bit backwards like this, because we're putting 10 inside this box that then goes in here. Now, we can also initialize variables without values in them. For instance, all I have to do is do this, and that variable has no value in it. Of course, it's going to have something really random inside of it. So if I try to display that, so I'll try to display that now, try to display favenum, it's gonna have some pretty weird stuff in it. It might have 0. Oh, for now it just has 0. But there are times when there's something like that. But like if I say that it contains 10, yeah, it now contains 10. So that's pretty cool. So yeah. And so another cool thing we can do is we can change what's inside this variable. So for instance, right now it's equal to 10, but I can say that, oh, now favenum is equal to 7. And then if we try to display that, If we try to display that, you can see that it's changed. It's now, it used to be 10, it's now 7. Okay? We can also, but we can, there are all sorts of different ways of doing that. So for instance, we can choose to define a variable and then we can put something new inside of it. So since there's nothing in there yet, it'll be 0, but then once we put something in, it's now 7. And we can also do things like define multiple variables. Let's say if I want to say A, B, C. Well, it's initialized all those different variables. And so now I've got 3 different variables inside that. And I can say that A is equal to B. I can say that B is equal to A and C is equal to B. And this is all valid. And I'll just say, I don't know, int A equal to 1. And so this should output 1 for everything. Oh, forgot to end. I'm just sort of showing a bit of about how we manipulate these things. Oh, it's not really pretty right now, but it's okay. We're gonna see that it equals 1. In the first part, it made something that looked like 100 because it didn't have a new line created. So it was 100. And it was because I said A is equal to 1 at the end. So this relation didn't work. But if I put this relation here, we can see that these variables are being used like this. 1 is stored in A, then A is now 1 and it's stored in B, and B is now 1, which is stored in C, and then I just display them all. So we can see how variables can allow us to do really powerful things. So right now, we are just fiddling around with this, but we'll learn in a bit that there's actually a lot more we can do, a little bit. But for now, that's a little bit of what we need. And now we'll get to basic input. So we've got output. So now let's learn about input. So let's say that we want to enter our favorite number. Okay? So we want to make a program that takes in our favorite number. So we define first int favenum, and then we use this new thing called Std cin, and it looks like that. And this Std cin uses this notation, and then we put it into the variable favenum. Now notice that this is different from cout. In Std cout, it looks like this. Now the way I like to think about it is that here, if you specify a variable like favenum is going out. Favenum is going to the console here. When we look at cin, we're seeing that whatever is inputted into the console goes to favenum. That's the way I like to read it, so that I remember the direction it is. So less than like that, going out. Greater than like that, going in. Okay? So just a little something to help you remember that. So what this will do is it will make our console request for a user input, and it will specify that that input has to be an integer. So then if we display this, We display this. So our console is going to ask for a number. I put 7. And now it returns 7. There. Of course, it's going to have an error if I try to give it something else. If I try to give it that, it's not going to understand that, and it's going to convert it to 0. So that's an example of something we can do. And we can also use this in interesting ways. So we can print out some stuff. Like, for instance, we can say, something like, something like that. So we can build a simple program that asks for your favorite number, lets you input it, and then tells you what that number is. So that's pretty cool. You can try this out yourself, and it should compile. Another thing you should be aware of, guys, is you should be careful of quotation marks. Like, we don't really do this inside our program, because then that confuses the compiler. It isn't quite sure what to do with it. So a good way to get around that is we can often say something like this if we want to display something to the compiler that allows us to show quotation marks. So if I demonstrate that, you can see this. But if it's like double quotes, it gets a bit confusing for the compiler. So just be careful when you do that, okay? Just a word of advice. Okay, next. We're going to now learn about a couple of things. Namespace and comments. So you might get tired of having to type std : everything all the time, right? So you could do something called using namespace std, which can make things a lot faster. Though do be warned that it's generally bad practice, because it's generally considered to be bad practice, especially if you're working at a company or if you're doing production level code. And the reason for this is because when we say using namespace std, we import the entire std namespace into our program. So for instance, if you use a library that has a similar sounding or a similar function in the namespace, for instance, we have a library that has cout as well, but has a different function, and we are including std namespace, then the compiler gets a bit confused about which function it should use. But it will just be something I will demonstrate so that you guys are aware. So using namespace std lets us get rid of all these lets us get rid of all these stds. So for instance, if we do this, suddenly we don't need std anymore to display cout. You can also do something called using the specific thing. So for instance, using cout, using std cout, and that will allow us to use std cout without an error, but only this particular thing. You can choose this to be a more safe option when you want to import a certain word. Although in general, if you can get it into a habit, it's best to just type things like, type the standard library like this, instead of having to import the entire namespace. But if you want to work on something unlike a project at home, and you just want to make it a bit quickly, well then, you can do this. Nothing wrong with it. You just need to be aware of what you're doing, okay? And then another important thing that has to be taught to you guys is comments. This is really, really important for C++ and programming in general, which is you want to be able to comment our code. So there's two ways of doing this in C++. We can go / like that, which will create a comment. Or we can go like this. So this creates a multi-line comment. So slash asterisk. So everything here is all commented out. Now what comments are is they are text that you can write in your program that gets ignored by the compiler. So it's a useful thing for programmers to put down what they were thinking in this part, explaining what this particular part does, and just think of it like notes. And so you want to get into a good habit of commenting your code, because if you give this code to someone else, and they don't quite know what you were thinking of when you were writing it, it might make it hard for them to understand certain aspects of your code. And also for your sake too, because if you're working on this code, let's say 2 months from now, and then you're looking at what you wrote, and then suddenly and you can't remember what it is, comments can help you out a lot in terms of knowing what your program was doing during that time. So there's nothing wrong with comments. You don't lose any performance or anything by doing them. So get into a good habit of commenting your code, because it really, really helps. And it's really easy to do. So that's comments in a nutshell. I'll leave that there. So now let's get familiar with a couple data types. So far we've talked about the int data type, or int, which stores only integers. So it does not store decimals. It only stores integers. So if you tried to input, let's say, a decimal, it wouldn't quite work here. Yeah, it would truncate it. It would get rid of that. So how do we display decimals? Well, there's 2 available data types for decimals, which is float and double. Here. Yeah. So float and double represent 2 data types that can allow you to make use of decimals. Float is often used for things like video games, stuff like that, graphics, etc. And the reason for that is because floats are often a lot faster for your computer to work with, because things like GPUs and other specific hardware for your computer are really, really good at calculating and working with floats. Doubles, on the other hand, are often used for scientific applications, numerical analysis, statistics, stuff like that, where you need precision. The keyword here is precision. And that's just because doubles can store a lot more values in it than floats can, but you suffer from a little drop in performance. So you just need to be aware that there are 2, floats and doubles, that exist. So we can demonstrate the behavior of a float or a double in terms of how it represents a decimal value by doing the following. So let's change the data type of favnum to a float or a double. Just wait a moment while REPL decides to reload. And it failed to reconnect. So just let me work on this for a moment. I think it will save. So if I change the data type of favnum into a float, for instance, now suddenly it can allow you to store decimal values inside that variable. So let us try to input a decimal value. Let's say that we want to put this decimal value. So now when we put in that decimal value, the program now allows you to output a decimal value here by using a float. You can also try the same with a double, and it should work out the same. So let's enter a number. And that should display that number over there. In general, doubles allow you to have more precision than a float does. So that's just something that you can keep in mind. So you can see how we can do all sorts of things with that. Let's then move on to the other data types. Okay. So aside from double and float, we also have another data type. I'll just put it all here. Should I just put all the data types here? So we have, so far we have int, we have float, we have double, we have, and now I'll introduce another one, and we have char. So char stands for character, and it's another data type that allows us to represent characters in our code, allows us to deal with characters. So there's two types of, So let's say we want to define, let's say we define a variable. So now if we display that, then we get the letter A here, okay? And so we can do all sorts of things here too. So for instance, we can do all sorts of things here too, because you see, when we create something called char, it corresponds to 256 values on the Ascii table. So if you take a moment to look at the Ascii table, if you type one of the letters there that corresponds to char, then you'll be able to represent it in your code. So I'll see if I can show that right now. And let's look at an Ascii table. So let's say I want to get big letter A is 65. So if I try to display this, display A. So you see how the decimal values here from the Ascii table, sorry for that, the decimal values here in the Ascii table correspond to the char there. I will also mention that there is also another data type called wide character, wchar underscore t. It would look a bit like this, which extends the sort of space, as it were, of characters that are allowable here. Although wchar underscore t isn't, or wide char isn't used so often anymore, thanks to UTF-8 encoding, it is still useful to know that it does exist. Because by default, the character or char can only take up 256 values, which corresponds to the entries in the Ascii table. While wide char can take on around 65,536 values, which roughly correspond to Unicode 4. But we're now at Unicode 6, so there's been a lot more in development. Now, it's often used, for instance, to handle things like kanji. Traditionally, it was used to work with Japanese, for instance. So just something useful to know that it does exist, but it isn't going to be fully useful for you right now. Anyway, moving on, we're going to move to the next data type, which is the next and the last data type, which is also one of the most useful, which is bool. So bool is very useful. Bool is a Boolean, and it holds a value of only true or false. So Booleans, sort of hold these truth values. So for instance, if we think of, for instance, a light switch is either on or off. So it's useful for us to describe these sorts of values. So, let's say I wanted to make my light switch, namespace switch. And I wanted to turn it on. So I set it to true. Now, if I ask for the value of my light switch, ask for that, it should return 1. Now you see the 1 here corresponds to true. So 1, I'll make a comment. So the 1 is equivalent to true, and 0 is equivalent to false. You can think, and that's sort of one of the basic ideas of Boolean. So these are the Boolean values that you work with. And there's really a lot that you can do with just true and false. But it's useful to get to know Booleans because it'll become more useful for you as you go on, especially when we start talking about loops, when we start talking about certain things where we want to have a value of either true or false. So, all right. So now all of these are built-in data types or primitive data types. So there are other types of data types, but it's not something we necessarily have to tackle right now. But these data types can be modified. And so how can they be modified? Well, we can modify how much memory it takes to store the value in the computer, for instance. So each data type has a limit on how much memory it can take up. But with these modifiers, you can change it. So primarily, there are 4 modifiers. There are 4 modifiers, which is signed, unsigned, short, and long. I believe that there will be lecture notes posted with this lecture, so you'll be able to look at the detailed description of these different data types. But in general, short holds a smaller value, and so there's a certain range. I'll actually just copy it so that you guys can see. Just copy that into the multi-line comment. Hopefully this is cool. Yeah, so we see here that we have the data type, we have the size in bytes, and the range. So for instance, these different modifiers, these 4 modifiers, can change this. So for instance, it's a bit screwed up, but it's okay. We see that there's a certain range that short, for instance, can go to. There's a certain range that unsigned short int can go to. There's a certain range that unsigned int goes to, etc., etc. So you don't really have to memorize this. You just need to know that that these things exist. So by knowing this, at least, you aren't going to be so surprised when we have to deal with things like signed, unsigned, integers, for instance, or signed, unsigned floats or something like that. So in general, it's just useful to keep this in mind, that these things do exist. Delete that for now, since you don't quite need to know the specifics of that, but you just need to know that there's signed, unsigned, for when we're dealing with positive integers, when we're dealing with positive things, when we're dealing with negative things, when we're dealing with shorter things, so we want to take up less memory, when we're dealing with longer things because we have a lot of memory and we want more precision. So that's the context in which we use. So we can also display the size of all data types using the size of operator and passing the keyword of the data type as an argument to the function. So arguments simply mean that a value is passed between a program or function. So they're independent items of variable that contain data or code. So I'll just copy and paste a little code snippet here that will demonstrate the size of all of this. So I will just comment out everything. Okay, this looks a little bit messy, but it's okay. comment that out for now. So let's say we have this, and to make things easier, we'll just okay. So here we can see, running this program, we can see the individual sizes of what these different data types and their modifications hold. And so you might be a bit surprised to learn that something as small as 8 bytes can hold so much in it. But that's just one of the beautiful things, I think, of computation and computers in general, is that very simple, from very simple ideas, from very basic things, we can construct and build complex and interesting programs that can be applicable to real-world problems. So that's something that we can do. All right, so I'll just comment that out. And I will bring back. Actually, no, I'll just start with this. Yeah. Okay. And I'll get rid of these. I don't really want to promote that in practice. All right, so now let's move on to the next part of the lecture, which is operator. Move on to operator. So we've looked at things like data types, we've looked at things like variables, we've looked at things such as input and output. But all of this is, still not really useful for us because we want to be able to do math. We want to be able to do mathematical operations on things. So here in programming, you can do things like adding, subtracting, and much, much more. So for instance, we can put this into the console, and it should output a value. And so when we put that into the console, we're going to get the value that we obtained by adding 174 and 10. So from this, we know that, we can do certain mathematical things. We can also do something like this. We can add variables together. Like so. So here we define 2 variables, and then we define this new variable, which is equal to this variable plus this other variable. And then we display the total. And so this nets us the same result. But now we've allowed our code to be more functional, so to be more usable in different contexts. Because what if I wanted to change the value that current book has? What if I wanted to do this? In the old one, let's say, imagine if it was a big program, you'd have to look for that thing. But if you define like it as in this manner, well, it becomes a little bit easier for you to make modifications to your code. So it's just a certain way of thinking about things to allow them to be encapsulable and portable as it. So like, if we change something, we don't get lost. We know what we changed, and we can put a comment there saying, oh, this variable holds this, and then and then it might hold different values in the future. So we can also do subtraction. In fact, all the things you'd expect from math, I'll just write them all right now. You'll have all these different wonderful little operations that you can do with your C++ program. I'll just type them here right now. So we have a couple things. We have addition, we have subtraction, we have division, we have multiplication, And we also have something called Modulo. Now everything else is a bit self-explanatory. Just add it in, just in case. The modulo is modulo, which also stands for finding the remainder. So for those unfamiliar with modulo, how it works is, for instance, if we wanted to find, for instance, 4 modulo 2, it would give us 0. It would give us 0. Now, if we wanted to find, for instance, 4 modulo 3, that will give us 1, because, well, 1's the remainder that we get. We try to divide 4 by 3, you're left with 1. So you'll find out a bit later how modulo can be very, very useful for you. For now, you might be wondering, how is modulo used? Why do we need this? Well, it makes certain things in programming a lot simpler for us, especially for things like checking if certain values will, checking if certain numbers are even, checking if certain numbers are odd, etc. So you'll see as you move on how useful it can become for you. Now, alongside these basic operators, if you play around with your program, you'll learn about all of that. So you can feel free to play around, mess around, and do all sorts of things with it. We can also do something called assignment operators. So, for right now, we're doing something like this, right? So now there might be a situation where you need to do something like this. A is equal to 1, and then you want to display what happens if you add something to int a. So let's say now you want int a to equal a plus, say, something else like 3. So want a to equal something like that. So then if we see out that, we get 4. But of course, this looks a bit bigger. Isn't there a way of doing this a lot in a more in a simpler manner? Well, you'd be happy to know that there's such a thing called a assignment operator, or sometimes called a compound operation, which works a little like this. So we just say a plus equals 1. And what that does is that, a plus equals 3. And what that does is, it just adds 3 to where a is, and adds 3 to where a is. So you can see that it's functionally equivalent to saying a is equal to a plus 3, but just smaller. So, you can use it to make a more concise, as it were, program. In fact, there's all the things that you see in your basic operators. You can also find them in the assignment operator. So, for instance, you have plus equals, minus equals, times equals, divide equals, even modulo equals. So with these tools, you can already start constructing some very interesting programs. So, okay, so I think that shows that. Oh, so I'll just show how you could rewrite the program we wrote before. So instead of saying that total books is equal to current books plus new books, we could just say, we could just do this in less variables. We could just say current books plus equals new books plus equals new books, and then display current books. So instead of this code, what we could do is then display current books. Then if we ran that, we'd get the same answer. Yeah. So you can see how it significantly shortens our code and makes it a lot easier to look at. So that's the benefit of using these assignment operators. They really come in handy when we want to do that. So now we can also learn about another trick that also comes in handy. So let's say we want to have a program, and each time we want to add 1 to it. And so we print out a number and add 1, then print it out again. So for instance, I have this. Show it to you now. I'll show it to you right now. I'll just comment this. And then let's say we wanted to do that. And then we could do it in a shorter way. We could do it like this. So, we can do that. But what if we could do it in a way that's even shorter? What if we could just do something called implement? And so now when we do that, it adds 1 to the thing. Now, right now it looks a bit simple, but you'll start to learn that in things like loops, this becomes really, really, really useful. And there isn't just increment, there's also decrement. We can do that, and we'll get 9. And we can also do it in different notations. And this does have slightly different functions. So for instance, we could do a postfix increment, but we could also do prefix. Now this is slightly different. It does the same thing, but it is slightly different because in this case, what you're doing is it references the original value x. So for instance, it will actually change this value if we try to display it again. So how do I explain this? Well, for now, you don't quite have to know the difference between post-increment and pre-increment. But there are certain situations where you want to use pre-increment because it gives you a slight speed boost, because it actually is referencing x directly instead of creating a new thing that then holds x. So there are situations where you'd want to do that, especially when you're dealing with certain loops and certain references and stuff like that. But for now, you don't quite have to know it too much. Yeah, but in the same vein, you also have prefix decrement like that, and so we can also do it like that. So this is really useful for us. It allows us to make our code much simpler. So every time you see something like plus plus, you can think of it as, oh, I added 1 to the variable. Or if you see something like minus minus, that means you subtracted something from the variable. Okay, so moving on. Let me just comment on it. Now, let's move on to something called static cast. So a cast operator is simply one that forces a data type to be converted into another data type. So static cast is the simplest type of cast which can be used. So for now, we'll only discuss this one. There are more, but this is just useful to know before we get into some more advanced stuff. So static cast does implicit conversions between types, but it can also do explicit types of conversions. So an implicit conversion is also known as automatic type conversion. Well, actually, no, sorry, that isn't static cast. The C++ program supports something called implicit conversion. And then when we use something like static cast, that is explicit conversion. I'll demonstrate. Sorry for the bit of the confusion. So an implicit conversion is also known as an automatic type conversion. This is done automatically by the compiler. So we can see how that works with this example here. So here we define a float x, which is equal to this. And so then we define a int y, which is equal to the value held in x. X is a float though, and y is an int. So then we want to display that. So if we try to display that, we're going to see that the y truncated the 5 from here. So it implicitly converted the value that you had there. So the compiler sort of did it for you. So the value of x, which is a float, was automatically converted to an int by the compiler. But we can also do something called explicit conversion, which is when we type something along the lines of this. So int b is equal to static cast int thing. So an explicit conversion is also called typecasting and is user defined. The user can typecast the result to make it of a particular data type. This means that you can convert compatible data types as well as incompatible data types. And it's much safer because you can safely handle different data types. This is also much better because you are telling them what exactly to convert and to convert it to what. So you can do an explicit conversion with static cast by doing something called static cast, and then in the angle brackets, type ID, and then the expression that you want to change. So how that we could demonstrate this is this. So we can demonstrate it by like here. And so we can see that it does the same thing. Now, this might look a bit of a hassle, as it were, because like, why would I need to do this? Well, for now, yeah, it does make sense that it is a bit of a hassle. I don't really need to do this all the time, but it will make sense more in the future. This will be more useful when we deal with things like memory and stuff, especially when we start talking about things like pointers, where we really have to be safe about how we deal with it. But at least that covers it for most of the first part of this lecture. Then now we have a certain task. And I think it's a sort of task that we can work together on. But I think that you can choose to do so. You can pause the video and then work on this task. So let's have a little bit of fun. So this task is known as mini calculator. So just sort of put it here in comments. So here we want to create, so far we've been talking about basic, so let's do something fun. So let's make a mini calculator which takes 2 inputs and then outputs the answer. The program will output the addition, subtraction, multiplication, division of the numbers. We'll take the remainder as well. So let's start first by initializing the variables we'll be using. We'll be getting 2 inputs, so we need 2 numbers, 1, num2. And then we will need to get the sum, difference, product, quotient, and the remainder. So we should use floats, doubles, in case the users will put in decimal points. So you can just pause the video right now and choose to work on this on your own. And then I will just walk through how I would go about making this mini calculator. So just feel free to pause right now if you want to work on it. So anyway, I will proceed towards how this is done. So first, let's define a couple variables. So shall comment out everything. Just need that. So let's start by initializing a couple of variables that will hold all the things we need. So I just want to try out double for now, just because I'm feeling a little precise today. And okay, so you can do something like this. You can initialize a whole bunch of variables all in one go using just a comma, and then now we want to get input from the user. So if you're wondering how I'm doing this, I'm just started copying pasting. I'm a bit lazy. I don't really want to type out all this stuff. And it's fine to be a little bit lazy, don't worry. Programmers are by definition a little bit lazy. And so the reason why we work hard on this is because we don't really want to work hard in the future. But anyway, so let's see. So here we have a bunch of doubles put in like that, and then we have the display enter a number, and then we input the first number into num1, and then we can say another thing, enter another number. So we can look at it like this. So here we see that we are doing the first parts of our program right there. And so then you could do it like that, or you could also do it like this, which is a bit easier. You could just say, for instance, you could just say, let's enter two numbers. Since cin allows you to do the same thing as cout, which is you can specify a bunch of stuff that needs to be cinned, and all that's going to do is it's going to tell the console that you need to input these two things. Okay. So then now we want our operation. So here, let's define a couple of our operations that we want to do. So here are all the operations we want to work on. And we also get to use static cast because the modulo operation only works on ints, does not work on doubles. So you want to convert it into a integer. Actually, I should have put that in the beginning. Just that guys wouldn't be surprised about that. But yeah, it's okay. And then we need to put in the program all the results of our calculation. Oh, sorry about that. Hit my mic. Apologies. Put in the all the results of our operations. Trying to be safe. So now that we have all of that, we should be able to print out everything. Oh. No, we forgot to comment on this one. Okay. Good there. Now that that's all been fixed, let's print this out. So let's enter number. Say I want to enter, then I enter another number. And so it obtains all of that. And so congratulations if you guys worked on it. I apologize. I hit my mic, so I might have had a bit of a audio glitch there. And there's also I forgot to mention that Modulo does not work with things that are not integers, but hopefully that this is a little exercise that you can work on, which is useful for applying all the things we've learned. So now we'll move on to the next part of the lecture, which is talking about arrays. So this is gonna get very meaty. Okay. So we move on to the next part of the lecture, which is C++ Lesson 1 arrays. So we're going to get familiar with what an array is, or std array, or std array. So let's first talk about arrays. What are arrays? An array is a collection of items sorted at contiguous memory locations, and elements can be accessed randomly using indices of an array. So they are used to store similar types of elements. So data types must be the same for all elements. Although there can be situations where this isn't always true. So let's say, for example, we have different books. We can have an array of Marvel comics, for instance, and then another array for literature books and so on. Now, the only way we can access them is through an index, which starts from 0 instead of 1. So in programming in general, we don't start at 1, we start at 0. So if you say you have an array of size 5, you start at 0, 1, 2, 3, 4, and then you end up with 1. So now, why do we need arrays? Well, there's lots of reasons why we might want an array. So for instance, it might be difficult to represent something with a normal variable, because a variable typically only stores one value. So what if you want to store 10 values into something? Well, you need a data structure known as an array to do that. So you can think of it as sort of like a way of dealing with data in such a manner that makes it a lot easier for you. So let's get started with how to use array. So we will use, in order to use array, we have to include array in the preprocessor. And then once we do that, we declare an array like this. So int array, this can only take 4 values. And to make my life easier, just for now, I'll just use always remember that this is bad practice. This is good for learning, but don't do this in the real world, okay? So here, we will declare an array that holds 4 values in it. And so, so this allows you to initialize the values of the array later. So for instance, let's say I wanted to define an array that holds 4 values, and I want the first value to be 10. So then I access the array at index, at the first index, 0. And so then if I open that, you'll see that it displays 10 because 10 is stored at the 0th index. So you can also initialize elements like this in a different way. You can do it like here. So you've initialized 4 values inside your array of size. So if you put in elements like this, what will happen is the compiler will automatically create an array that has a size of 4. So if you try to access the 0th value, you get 20, for instance. And so you can also do both. You can specify the size and then you can specify the size and what the array contains at the same time. You can do something like this. So the compiler creates an array that has a size of 6, but can initialize the other elements later. So let's say we specified only 4 elements. The array can store 6. We put in 4, and then later we want to put in something at position 5, for instance. Well, then now when we show position 5, we can see that it'll contain a value. So here. Now in position 4, we didn't initialize, in index 4, we didn't initialize anything. So it has 0 in it. But in index 5, which is the last index, remember 0, 1, 2, 3, 4, 5, we stored 100, so it's stored it here. And so you can also do this another way. You can do it like this. You can also initialize your array like this. So you can say array, and then it'll contain a set of integers. And then you specify how big the array is, and you name it R1. And then you specify what is contained in the array. So for this type of initialization, you need double braces. And then you access the element at index 0, and then you get 3. So those are all the different ways you can do and initialize an array. You can do it however you want. Now, there are advantages to arrays, such as that you can access different elements randomly using the index, you can use less code, and much more. But there are also disadvantages as well. One of them is that it only allows a fixed number of elements. Meaning if you don't know how many items you want in your array, well, then you've run out of luck. You also can't change your mind. Meaning if you want to add an item, well, you can either add one manually in the size, or change it with some other element. But this causes problems, because what if it's an array of usernames? How are you supposed to add a new user without changing your code every time a new user comes? So what do we do? Well, how are you supposed to deal with something where the size is not yet known? Or how do you make an array with sort of, in a sense, a kind of unlimited memory, or rather, it'll grow as my demand meets it? Well, there's such a thing called a vector. So now we will move on to Std Vector. So vectors are something like a dynamic array, which has the ability to resize itself automatically when an element is inserted or deleted. So we'll type this right now. So we are going to need something called a vector. And so its storage is handled automatically by the container, and the compiler just sort of figures out what they need. So basically, vectors are arrays that can change in size, and you don't have to give it a size. There is something to note, though, that vectors consume more memory than an array, but in exchange for the ability to manage storage and grow dynamically in an efficient way. So for instance, you might be able to use less memory with an array, but with a vector, you're sure that whatever changes happen with your code, it'll always be able to handle it. So let's learn how to initialize a vector. So we first have to include this new preprocessor into our preprocessor. So we need to include vector. Now, once we've included that, we can now initialize a vector. So let me just delete this. Excuse me. So to declare a vector, we do this. We say vector, and then what is going to be held inside that vector, and then the name. So you have to know that it's part of the Std namespace. If you take this out, you're going to need to type in Std Vector. Okay, just remember that. So to initialize an element, you say something like this. Let's put it into. So to initialize an element, you have to say this: name of the vector dot pushback, and then the value you want to put inside. So here, for instance, let's put an element inside this vector. So we are going to put the element 19. And so then what's happened is now 19 is at index 0 of the vector. Oh, and also if you try, it's not index 0 of the vector. Okay, so what if you want to know the size of the vector? You can do something called name.size and then parentheses. So you can do this to obtain the size of the vector that you are dealing with. So here. So it should say 1 because it only has one element inside the vector. So it tells you that it's a vector with a size of 1. Okay? So what if we want to clear the vector? We can do something called here. Name, we can just put comments. Yeah. So then if we run this and type in, and then we try to access the vector again, so we can do this thing called num.clear, which will remove the how do you put it? Remove the elements of the vector, but it will not remove the data stored in it. So for instance, if you try to look at the size of the vector now, you're going to see that it now has a size of 0. But if you try to access an element at the vector's index, say at index 1, well, it's going to show you 19. Because that's what's in, oh, sorry, no, 0. Would you? Yeah, it's going to show you it's going to show you 19 because it didn't delete the value stored in that index. It only deleted the elements, as it would. Yeah, elements that are inside the vector. So if you wanted to delete something, you can remove an element by saying name. You can remove the elements by doing something called name the vector dot erase, which would delete all of that. So for instance, we do num dot erase, and yeah, let me just comment. Which would work, but in this case, we're going to need a iterator. So we're going to need to iterate between two different things. So not really the best to show it right now, but it is useful to know this, because basically you're going to need to go through the first in this and where it ends. So you're going to need to erase this element, the first element, and then the last one. Although you don't quite have to show that right now. It's just useful to know. And then there's also other modifiers that you can check and experiment with, such as dot swap or pop back, etc. You can learn about this on your own in your as you explore C++, and I highly encourage it, because even in lectures like this, I couldn't begin to cover everything there is to learn about C++. You have to think about it, or you have to approach it like you would learn it, like you would in learning another language. Because, for instance, you can develop a fluency in C++, which would allow you to learn how to approach different problems much more effectively. But even the most advanced people still stumble a little bit or have, a couple errors every now and then, and there's nothing wrong with that. Your code doesn't have to be perfect every single time. And so things like debugging, IDEs, IntelliSense, code review, all sorts of things exist to make life easier and to check for errors and all sorts of things. So, don't worry too much if you aren't the most amazing C++ programmer. Just worry about building up those fundamentals and getting familiar with how to work with the language. So then let's move on to the final sort of topic of this lecture for beginners, which is Std string. So we've learned about all these different ways of manipulating vectors and all such. And I'll just comment this all out. Comment this all out. So now let's learn about this thing that allows us to manipulate text. And so a string is just a sequence of characters. So it's a collection of characters surrounded by double quotes. And there's sort of a rationale for why we kind of did this after we talked about vectors, arrays, and stuff like that. It's because a string is a very special kind of data structure in C++. In other languages, it's a bit more, it's handled in a different way. But here, a string can kind of be thought of as like a collection of chars, of characters. And so you can kind of think of it like an array, like a box of characters that you put in a sequence. So in order to use string, first we have to include in our preprocessor, include string. So then once we've included that, you can then go ahead and start declaring a string. So for instance, declare a string, you just type this. Just type into your int main string, and then the name of the string, okay? And so then you can place something inside the name of your string. So you can put in that it's now equal to this word. So it's a bit similar to how we work with math. But if you noticed before, cin doesn't work with sentences. But what if I want to ask someone for a suggestion? Well, we can do something called getLine function. This allows you to get the line from the user. So to use a getLine, you do getLine cin, and then name of the string. Okay, so here. So for instance, we have this code here. And so then say, and so then it takes in the line that I entered, and then it returns it as it stores it in the variable greeting, and then it's now stored in greeting, and so then I now see out it to show what the user then inputted. So if I put in something else, let's say, if I put in something else, it's going to return that. Okay, so that's pretty useful. So you can also do different things, such as push back, which adds a character at the end of the string. So for instance, we do this. So here we have string greeting and then enter greeting, and the same thing, and then we push back this character. So let's say I put in a greeting. And so it will put a exclamation mark at the end of that string. So isn't that damned? You can also do something called pop back, which deletes the last character from the string. Here, you can do something called pop back, which deletes that. Say, so here you see that the exclamation mark has been deleted. Also, if I remember correctly, I think it's also can allow you to store a character into a different variable. We'll learn about that a bit later. So you can also do string concatenation. So the word concatenation, if you aren't familiar with it, means to join together. So to concatenate means to join together. So you can also concatenate strings. So for instance, we can do this. For instance, we have a string with greeting start, hey, and then we have greeting end, and then we add those two strings together, and then we display this, and so we get hey person. So we can do sorts of cool stuff with strings like that. You can also do this by using something known as the append function. So you can append to the end of the string like that. And so then greeting start dot append, and then the string that you want to put at the end. So that will do the same result. Get you the same result there. So if you want to know the length of a string, well, you can do something called you can call the length function. So we've appended this at the end, and so we want to get the length of this. So then if you run that, it's going to tell us 11. And it's 11 because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 11 characters in that string, including the space here. So you can also use something known as dot size, which would also give you the same result. Here, and use dot size, which would also give you the same result. And you're kind of seeing here how strings are a bit similar to arrays in that regard, because they have they have sort of certain length, as it were, which could be thought of as the indices. So it's just sort of something interesting that you can think about, ponder a little. And so you can also use the at function to extract a character from a given string. So for instance, here, so we have the same thing that we typed in, and then we want to extract the 5th character. So we count 1, 2, 3, 4, 0, 1, 2, 3, 4, 5. So remember, it's like an array. So we start at 0, the 0th index, and we go 1, 2, 3, 4, or 0, 1, 2, 3, 4, which would give us E. See there? So you can also access the character by referring to its index. So we don't necessarily have to say at. We could also do it like this. We could refer to the index, which is the 5th element, the 5th index, which would give us E. 0, 1, 2, 3, 0, 1, 2, 1, 2, 3, 4, 5, E. And you can also change string characters by referring to the index number and using single quotes. So for instance, here, you can change character at that index. So now when we do this, you're going to see that it changed the 5th, the character at index 5 changed L. So you can see sort of the similarities of it. And I think that's about it for strings. And so I believe that we'll also get some sort of tasks and other activities that you guys can work on. But for now, I hope that this has been a helpful guide in learning about C++. If there's any questions, you can always feel free to ask anybody in the C++ channel. We're very helpful in that regard, and I think there'll be lots of TAs that can help you out if you have trouble with your code. And don't feel bad about asking. It's always good to ask, because you learn a lot, especially when you're starting out. You don't have to worry too much that, oh, I don't know, my code isn't working so well. It's okay to ask, and it's okay to learn, and that's what you do. You make mistakes, you learn from them, get up. So that's all for this particular lecture. If there's any suggestions that you have on how I can improve my lecturing style, or any ways that we can improve how the lesson works, feel free to do so. And I hope you learned a lot from this. Thank you for listening, and take care. Stay safe.